Science has revealed astonishing truths about the universe. We know that the universe is about 13.8 billion years old. We know that atoms form stars, planets, and life. We have mapped the human genome, detected gravitational waves, and even photographed a black hole. Yet despite these breakthroughs, the deeper we explore reality, the more we encounter mysteries that remain unresolved. Some of the most fundamental questions about existence still have no clear answers. These questions sit at the frontier of physics, biology, cosmology, and consciousness research. Below are some of the biggest scientific mysteries humanity is still trying to solve. 1. What is dark matter? One of the greatest puzzles in modern physics is the existence of dark matter. When astronomers observe galaxies, they notice something strange. The stars at the outer edges of galaxies move far faster than they should if only visible matter were present. According to gravitational physics, those galaxies should tear themselves apart. But they do not. Something invisible is providing additional gravitational pull. Scientists call this unknown substance dark matter. Dark matter does not emit light. It does not absorb light. It does not interact with electromagnetic radiation. Yet it exerts gravity. Current observations suggest that about 85% of the matter in the universe is dark matter, meaning that everything we can see, stars, planets, gas, dust, and even humans, represents only a small fraction of the universe's total matter. Scientists have proposed several candidates. Weakly interacting massive particles, WIMPs, axions, sterile neutrinos, primordial black holes, but despite decades of experiments, no direct detection has been confirmed. Dark matter may represent an entirely new form of particle physics. 2. What is dark energy? If dark matter is mysterious, dark energy is even stranger. In the late 1990s, astronomers studying distant supernovae made a shocking discovery. The expansion of the universe is accelerating. According to gravity, the expansion should be slowing down. Matter should gradually pull everything back together. Instead, the universe is expanding faster over time. Something is pushing space apart. Scientists call this force dark energy. Dark energy appears to make up about 68% of the entire universe. This means that normal matter equals approximately 5%. Dark matter equals approximately 27%. Dark energy equals approximately 68%. The majority of the universe is something we do not understand. Some theories suggest dark energy may be vacuum energy, a property of space-time itself, a new scalar field, evidence that our understanding of gravity is incomplete. If dark energy continues accelerating expansion indefinitely, the universe may eventually end in a scenario called the Big Freeze, where galaxies drift so far apart that stars burn out and everything becomes cold and dark. 3. What happened before the Big Bang? The Big Bang theory describes the origin of the observable universe. According to current models, the universe began about 13.8 billion years ago from an extremely hot and dense state. But this raises an obvious question. What existed before the Big Bang? The difficulty lies in the fact that time itself may have begun at the Big Bang. If time started there, asking what happened before may be like asking what is north of the North Pole. However, scientists have proposed several possibilities. Quantum cosmology, some theories suggest the universe emerged from a quantum fluctuation in a vacuum. Cyclic universe. Another idea is that the universe undergoes endless cycles of expansion and collapse. Multiverse theory, our universe might be just one bubble in a vast multiverse where countless universes constantly form and disappear. Currently, no experiment can confirm which of these ideas, if any, is correct. 4. How does consciousness arise? One of the deepest mysteries in science is consciousness. Your brain is made of about 86 billion neurons, each communicating through electrochemical signals. Neuroscience has mapped many neural processes that correlate with thoughts, emotions, and memories. But there is still a profound mystery. How does physical brain activity produce subjective experience? Why does a pattern of neural firing create the sensation of seeing color, feeling pain, experiencing emotions, being aware of existence? This problem is often called the hard problem of consciousness. Several theories attempt to explain it. Emergent consciousness. Consciousness may emerge from complex neural networks. Integrated information theory. Consciousness may arise from how information is integrated within a system. Quantum consciousness. Some scientists speculate quantum effects may play a role in brain activity. However, no theory has yet been proven. 5. Why does the universe follow mathematical laws? One of the strangest observations about reality is that the universe follows mathematical rules with extraordinary precision. Equations describing gravity, electromagnetism, and quantum mechanics accurately predict the behavior of nature. For example, Einstein's equations predicted gravitational waves decades before they were detected. Quantum mechanics predicts particle behavior with astonishing accuracy. This raises a philosophical and scientific question. Why is the universe mathematically structured at all? Is mathematics something humans invented, or is it a fundamental property of reality? Some physicists believe the universe itself may be a mathematical structure. Others argue mathematics is simply the best language humans have for describing patterns in nature. This question touches the boundary between physics, mathematics, and philosophy. 6. What is inside a black hole? Black holes represent regions of space-time where gravity becomes so intense that nothing, not even light, can escape. At the center of a black hole lies a point known as a singularity, where density becomes infinite and known physical laws break down. Einstein's theory of general relativity predicts singularities, but quantum physics suggests they should not exist. This conflict between general relativity and quantum mechanics reveals a deeper problem. Our theories of physics are incomplete. Understanding what truly happens inside black holes may require a unified theory known as quantum gravity, which scientists have not yet fully developed. 7. Are we alone in the universe? The observable universe contains hundreds of billions of galaxies, each containing billions of stars, many with planetary systems. Statistically, life elsewhere seems likely. Yet despite decades of searching, we have found no confirmed evidence of extraterrestrial civilizations. This paradox is known as the Fermi paradox. Possible explanations include: intelligent life is extremely rare. Civilizations destroy themselves. Alien signals are too weak or rare to detect. We are early in cosmic history. Large projects like the Search for Extraterrestrial Intelligence, SETI, continue scanning the sky for signals. But so far, the universe remains silent. 8. Can we unify the laws of physics? Modern physics relies on two extremely successful theories. General relativity explains gravity and the large-scale structure of the universe. Quantum mechanics explains the behavior of particles at the smallest scales. Both theories work extremely well within their domains. However, they are mathematically incompatible. Scientists have been searching for a unified framework known as a theory of everything that can reconcile both. Possible candidates include string theory, loop quantum gravity, quantum geometry models, but none have yet been experimentally verified. Final perspective science has answered many questions about the universe, but the deepest mysteries remain open. We still do not know what most of the universe is made of, what existed before the Big Bang, how consciousness emerges from matter, whether intelligent life exists elsewhere, how to unify the fundamental laws of physics. These unanswered questions represent the frontier of human knowledge. Every generation of scientists pushes the boundary further, turning mysteries into understanding. But for now, these questions remain among the greatest puzzles humanity has ever faced, and solving them may transform our understanding of reality itself.